Masters in Chemistry from IIT BHU. So in this video lecture, I will cover the basics of vapor pressure and the vapor pressure of solution containing volatile liquid. So let's start. So the word vapor pressure. The word vapor comes from evaporation. And we all are familiar with the word evaporation. So let us consider a closed container having liquid A, and the molecules of liquid can be represented as A. So these are the molecules of liquid A. So we can see that there are some surface molecules and there are some bulk molecules. The surface molecules have less force of attraction because these molecules are feeling force of attraction only from one side, while the bulk molecule, these are experience force of attraction from all the sides. What does it mean? It means the bulk molecule will have high force of attraction while the surface molecule have low force of attraction. These are surface molecules and these are bulk. So what we can see, the surface molecule have less force of attraction while the bulk molecule have more force of attraction. So these surface molecule will evaporate first and the bulk molecule will remain in the container. So here the two phenomena work. First one is evaporation. These molecules will evaporate, and as we know the container is closed, so phenomena of condensation will also take place. Basically, condensation is the phenomena in which vapors are converted into liquid. So what we can see, the two phenomena will work. First one is liquid converting into vapors, which is known as evaporation. Second is vapor convert into liquid, that is condensation. So there is equilibrium between liquid and vapors. So in closed container, in only closed container we have the phenomena of evaporation. So from all this we can conclude the definition of vapor pressure. So what will be the definition of vapor pressure? In equilibrium, the pressure of gases above the liquid surface is known as vapor pressure. So in equilibrium, the pressure of gases above the liquid surface is known as vapor pressure. I hope you all get it. So as we can see, these are the vapors. These vapors are in gaseous form. So these gases must have their own vapor pressure. So which can be represented as P naught A. P naught A is known as the pure vapor pressure of liquid A. P naught A. P naught denotes the pure vapor pressure. So it is the pure vapor pressure of liquid A. So this is all about vapor pressure. Now we will discuss about the factors affecting vapor pressure. Now let's discuss about the factors affecting vapor pressure. So first one is size and shape of container. So what do you think? Did vapor pressure depend upon size and shape of container? So the answer is no, because vapor pressure is property of liquid, not the container. So the size and shape of container did not depend upon the vapor pressure. So size or shape of container is independent on vapor pressure. Second one is temperature. So vapor pressure is dependent on temperature, because as we increase the temperature of liquid, then more evaporation will take place, and if evaporation is more, then vapor pressure of the liquid will also be high. So the second point is temperature. Vapor pressure is depend on temperature, because as we increase the temperature of liquid, the more evaporation will take place and vapor pressure will increases. So temperature is directly proportional to the vapor pressure. The third point is nature of substance, which is most important. Based on the nature of substance, we have two types of liquid: volatile liquid and non-volatile liquid. So we can categorize the substance into two categories: volatile liquid and non-volatile liquid. So volatile liquid are those which have high tendency to evaporate. So they can evaporate easily. While non-volatile are those which do not have tendency to evaporate or have very less tendency to evaporate. So the example of volatile liquid are water, ethanol, benzene, etc. And the example of non-volatile liquids are urea. So based on the nature of substance, there are two types of liquid: volatile and non-volatile. Now we will discuss about the example of volatile liquid. Water and ethanol are example of volatile liquid. So how can we find which one is more volatile on the same temperature? So as we know, water have O and H, so it will do hydrogen bonding. Ethanol have formula C2H5OH, so it also have tendency to do hydrogen bonding. That means both water and ethanol will do hydrogen bonding. H2O. So water and ethanol both are able to do hydrogen bonding, but so how can we differentiate? So one molecule of water will do 4 hydrogen bonding, while one molecule of ethanol will do only 1 hydrogen bonding. So as we know, if hydrogen bonding is more, then force of attraction between the molecules will be large. And if hydrogen bonding is less, then force of attraction between the molecules will be less. And vapor pressure is about force of attraction. If force of attraction is less, then molecules will evaporate easily and have high vapor pressure. Whether if molecule have high force of attraction, then it will evaporate less and have vapor pressure less. So as we can see that the water have more force of attraction, and ethanol have less force of attraction, we can easily conclude that the vapor pressure of ethanol is high. The vapor pressure of ethanol is high. So this is how we can compare the volatility of water and ethanol. Now we will discuss about the vapor pressure of solution containing two volatile liquids. Vapor pressure of solution containing two volatile liquids. Now we are familiar with the word vapor pressure and volatile, non-volatile, everything. So we can easily find vapor pressure of solution. Vapor pressure of solution containing two volatile liquids. For this, we will consider two closed container, one of solute and second of solvent. So we have a solution in which we have solute particles and solvent particles. The molecules of solute are represented by B and the molecules of solvent are represented by A. And we are considering that solute and solvent both are volatile in nature. So what will be the pure vapor pressure of solute? So it will be P naught B. Pure vapor pressure of solute B. What will be the vapor pressure of solvent? So it will be P naught B, P naught A. Pure vapor pressure of solvent particles. So to find the vapor pressure of solution, we are now considering two closed containers. This is the container of solute particles. Second one is the container of solvent particles. And they will both combine to give the solution. So this is the container of solute particle. The solute particles are represented as B. So these are the surface molecules, they will do evaporation. These are the vapors. So what will be the vapor pressure of these vapors? So for solute particles we have vapor pressure P naught B, because this is the pure solute. In this container there is no mixing. So the vapor pressure of pure solvent is P naught B. Pure solute is P naught B. Now we will find the vapor pressure of solvent. These are the particles of solvent. They have some vapor pressure and their vapor pressure is denoted by P naught A. So in pure solute and pure solvent it is easy to find the vapor pressure because there is no mixing, so we can easily find their vapor pressure. For solute it is P naught B and for solvent it is P naught A. Now to find the vapor pressure of solution. In the solution container we have both type of particles, solute as well as solvent. So in surface also we have both type of particles. So how to find the vapor pressure of these solution particles? Because in this both there is a mixture of solute and solvent, so we can't exactly say that there is X number of A and Y number of B. So to find the vapor pressure of these type of solution, we have a law which is known as Raoult's law. So now we will discuss about the Raoult's law. So according to him, the partial pressure of the solution is directly proportional to the mole fraction of that gas. So according to Raoult's law, the partial pressure of gas A in the solution is directly proportional to the mole fraction of gas A. So this is the Raoult's law. Also for B, we can write the partial pressure of B is directly proportional to the mole fraction of gases in solution. So in the Raoult's law, if we remove this proportionality constant, we will get a constant. So PA is equals to P naught A x mole fraction of A. For B, PB is equals to P naught B and mole fraction of B. So this is the Raoult's law. So Raoult's give the relationship between the partial pressure and the pure vapor pressure. So these are the partial pressure of PA and PB. So if we will know the partial pressure of these gases, we can also find their partial pressure in the solution. So for solution we have both A and B. So for solution we can write the total pressure is equals to PA plus PB, because the solution containing PA as well as B. So we will add both, and this addition will give the total vapor pressure. So PT is equals to PA plus PB. For PA we can write this P naught A mole fraction of A plus P naught B mole fraction of B. So this is the final expression by which we can easily calculate the vapor pressure of solution. So that's it about the vapor pressure of solution containing two volatile liquid. By this formula we can easily calculate the vapor pressure of any solution containing two volatile liquid. And after that we will do a numerical problem based on this concept. So let's do it. So in this numerical problem we have 0.01 moles of benzene and 0.01 moles of toluene. They are mixed together to form a solution. And also we know that benzene and toluene both are volatile liquids. So this is the mixture of two volatile liquids, and it is given that the pure vapor pressure of benzene and toluene is 400 mmHg and 200 mmHg. So what we have to find? We have to find the partial pressures of benzene and toluene. So we have, according to Raoult's law, we have the relationship between partial pressure and pure vapor pressure, which is P of benzene, that is partial pressure of benzene, is equals to pure vapor pressure of benzene multiplied by mole fraction of benzene. For toluene, we have same formula. Partial pressure of toluene is equals to pure vapor pressure of toluene multiplied by mole fraction of toluene. So we have given the pure vapor pressure, we have to find the vapor pressure of benzene, so and we have given the moles. So by the help of moles we can easily calculate the mole fraction. The formula for mole fraction is moles of benzene divided by total number of moles. So moles of benzene is 0.01 mole divided by total moles. Total moles are moles of benzene and toluene. So 0.01 plus 0.01. The answer will be 0.01 divided by 0.02, that is half. For toluene, we can find the same. Also we know that the sum of two mole fractions is equals to 1. So for mole fraction of benzene plus mole fraction of toluene is equals to 1. For benzene it is, so for benzene we have calculated it is half. So So we can put half is equals to 1. Mole fraction of toluene is also half. So we have find the mole fraction of both benzene and toluene. Now we will put the values. Partial pressure of benzene is equals to P naught of benzene is 400 mmHg multiply by mole fraction. So it will come 200 mmHg because mole fraction is unitless. So the unit of partial pressure will be equal to the pure vapor pressure. For here, P toluene is equals to the pure pressure is 200, mole fraction is half, so it will come 100 mmHg. So using these formulas, we can easily solve these type of numerical. So this is all for today. I hope this lecture will be beneficial for you, and thank you so much.